Hello, Andy here, and welcome to my series all about laser diode cutters. I've been wanting to purchase a laser for many years, but now I have a diode laser and I'm very excited. Though it's not as powerful as a CO2 laser, it will engrave far better as it has a smaller spot size, and it will have limited but not unusable cutting abilities for like thin wood, maybe 6mm, hoping it will cut through 6mm MDF. Acrylic for certain, but not clear acrylic, and other materials. This is going to be my record of many experiments using it, modifying it and making it more user friendly and making it cut thicker materials. So if that flicks your switch, stick around. I need to cover some safety aspects in this first introduction video into my laser series. And how many videos, you ask, will I be making? Well, as many as it takes really. I would imagine at least 30 or more. I see it being a long, in-depth, deep dive into the world of diode lasers. We have so much to cover. Though these are low powered, they are certainly not toys. Even a half a watt diode can blind you quicker than you can blink. Very dangerous if not respected. So you should never leave the machine unattended while in operation. The risk of fire is real. Always have a water spray bottle and a CO2 fire extinguisher within arm's reach. Do not rely upon the built-in fire detection devices that your machine may have to warn you. These generally will only warn you and perhaps stop the diode from lasering and moving, but it won't suppress the fire. These units emit a parallel ray of light in a single waveform. The diode lasers are around 460 nanometers, I believe, plus or 5, which when focused into a small spot or a small rectangular beam, and we'll cover more of that in the videos. And at this time, I'm unsure the size of my spot size. The manufacturers tell me it's 0.06 by 0.06 millimeters. And that's one of the main reasons I purchased the laser that I have finally purchased. Out of my own money, this is not a sponsored video. So I hope that it will cut quite well and engrave with some great detail, especially doing the photo engraving. But we will certainly be doing some beam testing sizes to see whether the beam changes when you apply, say, 10% or 100% power. I've purchased a 10 watt unit as I feel it's a good starter unit, and I hope it will do exactly what I need. So photo engraving and cutting 4 to 6mm ply or MDF. You can see these beams with your naked eye. It's a blue light, unlike CO2 beams which are invisible. You should never look at the beam or any reflected light from it. The lasers I have a red shield around the laser beam, and this helps to safeguard against any light reflecting into the working space. But it's very, 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 very important to always wear rated safety glasses whenever the machine is cutting or engraving. So what will I hope to be cutting and engraving? Well, there's a small list of materials: paper, cardboard, untreated wood, MDF, plywood, natural leather, coloured acrylics, engraving on slate, white tiles, terracotta, and maybe marking some stainless steel. But we'll have to test this in the videos. I know I've seen others do it, I know it can be done, but I am going to do all my own testing and make all my own parts. Now here's a warning. Now please pay attention to this because this is vital. I've seen some people on YouTube doing this, and one bloke was so happy that he could cut Lego bricks. Do not try and cut or engrave Lego bricks. They are made of ABS. I'm just going to run through some of the materials, not all of them, but some of the materials you should not laser. And that includes ABS, a good example of that is a Lego brick, nylon, polypropylene, polystyrene, and that's like the old white ceiling tiles and packing material, epoxies, polycarbonate, and any material that contains PVC. These materials are not suited to be laser cut as they produce toxic gases, and some of these gases may even be lethal fumes which will damage your body inside and out, and they will also attach to your machine on the metal parts and rust them badly. So the bad plastics may also produce hydrochloric acid, hydrogen cyanide and hydrogen fluoride. So if that doesn't scare you, I don't know what does. No matter how good your ventilation is, these materials should not be used. Again, you might see people online saying, "Oh, I've got great ventilation, it's going outside." It's not a safe thing to do. One, you're still putting yourself at risk, you're damaging your machine, and if, like many other people, you just venting it outside your window, where is all that toxic gas going? Into your neighbour's yard. That's not a good thing, is it? Anyway, always refer to a materials data sheet if available, or do some non-laser testing on the material before you laser it to see whether it's safe. I hope I have not scared you, just want to make you aware of the potential dangers, but in these videos we're going to have lots of fun and we're going to learn lots together. We are going to discover what materials can absorb light. The ones that will absorb light will cut and engrave far better than those that reflect it. An example of a material that reflects the light is clear acrylic. These blue diode lasers cannot cut clear acrylic, but coloured is no problem. Now, jumping ahead a little bit, if you have a cutting surface which has a protection plate and it's made of aluminium, please be aware that the beam will be reflected off this surface very easily, as it only absorbs about 1% of the light. And we're going to cover more about the dangers of reflected light in upcoming videos. These blue diode lasers, as I just said, cannot cut clear acrylic, but with some tricks we can engrave or mark it on its surface and then use LED lights to make things show up, or paint the back of it to do desktop lights. I am going to investigate focusing of the beam, its focal length, and we're going to do that by some ramp testing, and again we're going to have videos to cover that. These videos I hope will be a two-way communication with you asking and hopefully answering questions within the chat at the bottom under the video description. I have to admit, I'm no expert, I am an engineer, I do like learning new things, and this is a new hobby for me to keep the old brain active. We'll quickly investigate ways to cheaply increase the abilities of the laser by adding something called air assist. Now, very crudely, that's trying to blow air through and down the very small gap called the kerf that the laser has just cut in your material, and that removes the smoke and the debris, and that helps increase the cut quality and the cut depth. Again, videos to follow. A way of extracting the smoke is essential, and we will cover how important this is in later videos, especially when cutting things like plywood, MDF and cardstock, as these may contain glues and binding agents that are not good for your health and could be classed as carcinogenic. Now, with all the warnings out the way, yes, I have purchased a laser. We are going to have fun with it, and stick around and you can see what we get up to. Cheers for now. That's Andy signing out. Many thanks for sticking around to the end of the video. You might like to watch some of these videos popping up on your screen now. Let me know what you think in the comments.